Chapter 15, question 13 on textbook, page 538. Equilibrium constant Kc for this reaction. Two HCl gas. Breakdown itself. Generate H2 and Cl2. And this reaction is Kc is 4.17 times 10 to the negative 34th power at 25 degrees Celsius. Ask you, what is equilibrium constant for the reverse reaction? For the reverse reaction is H2 react with Cl2. Oh, sorry. H2, let me rewrite. So reverse reaction is H2 react with Cl2 gas produce HCl gas. Oh, at the same temperature. Yeah, because heat depends on temperature. Yes. Kc equals to this number for this forward reaction. This is a reverse reaction, right? So these reactions, Kc will label Kc prime equals to HCl raised to second power divided by H2 and Cl2, right? Where Kc equals to what? Kc is for this one, right? So H2 Cl2 in top and HCl second power in bottom, right? So you find their relationship. So this equal to reciprocal of Kc, right? The replace switch numerator with denominator, right? Plug into number 4.17 times 10 to the negative 34. This will be 2.4 times 10 to the 33. Mathematically, how to do this in your calculator? I will say, don't put exponent in the calculator. You only need this. 1 divided by 4.7 in your calculator. This will give you 0.240 times, this is 10 to the negative 34 in denominator. So flip over is 10 to the positive 34. Then reduce 1 to 33. 0.24 becomes 2.4. Don't put the exponent in the calculator. This makes it much easier. Are you okay with this? So reverse reaction. This is the reverse reaction of this. The equilibrium constant is a reciprocal of the forward reaction. So relationship. of reverse ration, forward ration. Let's say question 15. Question 15. Ask you, what is a Kp at 473 degrees Celsius for this reaction? 2CO react with O2 produce 2CO2. And the Kc is 2.24 times 10 to the 10⁻² power. At this temperature, as you calculate the Kp at the same temperature. This actually asks you the relationship between Kp and Kc. The relationship between Kp and Kc, do you remember? The formula is Kp equal to Kc times RT raised to delta n's power, delta Ng. Right? Kc is a known value. R gas constant is a known value. T is temperature in Kelvin, of course. We need to convert the Celsius into Kelvin, right? So we need to figure out delta Mg first, right? What is delta Mg? The moles of gas in product minus moles of gas in reactants, right? For this case, moles in product side, 2, right? Carbon dioxide is a product, is 2. Moles in reactant, 2 more CO, 1 more O2. Be careful, no number means 1. Okay, so the difference is -1. And we also need to convert this T to Kelvin. So 1273 Celsius degree plus 273 give us 1546 K. More accurate is 273.15. You use 273 is fine. Okay. Now we can use this formula. Kp equal to Kc times RT raised to delta n's power. Kc tells us 2.24 times 10 to the 22nd power. R is a gas constant. We use 0.08206 liter ATM per mole per K. Times T is 1546 K. Raised to -1's power. This gives us 1.76 times 10 to the 20th power. Okay, so this Kp-Kc relationship, you need to remember this formula. Question 15. Next, question 17. Consider this reaction. N2 react with the O2. produce 2NO. If the equilibrium partial pressure of N2, O2, and NO are so PN2 is 0.15, PO2 0.33, and PNO is 0.05. So tell us each gas is a partial pressure as you calculate the Kp. Let's find the pressure at 2,200 degrees Celsius. As you calculate the Kp. Is this easy? Yes, easiest cannot be easier than this. So what you need to do is you need to understand what is the Kp. Based on this balance equation, it should be PNO raised to second power, right? Because this is the balance equation tell you 2NO. Then denominator PN2 and PO2. Do you understand this formula? Okay, whenever give you a balanced equation, you are required to write equilibrium constant, either in P or in terms of C concentration. This is Kc. Because here tell us partial pressure and ask the Kp, of course, is Kp. PNO is 0.05. PN2 P0.15, PO2 0.33. We use the calculator. Easily get this Kp is 0.051. Excuse me. Okay, are you okay with this? Okay. Then next, 33. Question 33. The equilibrium constant Kc for this reaction H2 react with Br2 produce 2 HBr. The equilibrium constant Kc for this reaction is 2.18 times 10 to the 6th power at 730 degrees Celsius. Starting with 3.2 moles HBr in a 2-liter reaction vessel. Starting with 3.2 moles HBr in a 2-liter container or vessel. After you calculate the concentration of H2, Br2, and HBr. So we need a list, a table to figure out each reactant and product concentration when reaction reach equilibrium. So we need a list. Initial Since here asks you concentration of each of these species after reaching equilibrium, so we need list the initial concentration, right? What is the initial concentration? 3.2 mole in 4 liter. This is mole, this is liter, is concentration, right? So initial concentration of HBr is 3.2 divided by 12. Right, this is initial concentration. How about this two? Because here tell you, starting with 3.2 more HBr in 4 liter vessel. This means no H2, no N2, no Br2 there. So use calculator, 3.2 divided by 12 is 0.267. Initially only HBr there, no H2, no Br2. Change. We let the change for H2 be X, then Br2 versus X, because it's 1-to-1 ratio, right? And HBr will be 2X. So this time, starting with HBr, this means no H2, no Br2 there. Then this reaction actually is from right to left, right? So actual direction is from right to left because starting with this only. So the actual reaction is from HBr to H2 and Br2. This means HBr actually is a reactant. And starting with this and then nothing, no H2, no Br2 there. This serves as a reactant in this direction. So this 2X will be negative. Then these two will be positive. Okay. This is critical. Can you understand this idea? If starting with H2, Br2, then this reaction possibly from left to right, then X will be negative. But now starting is HBr, no H2, no Br2. So cannot be from left to right. Must be right to left. This serves as a reactant. So this is minus 2X. And these two will be positive, produced. Then when reach equilibrium, this will be X, this will be X, and this will be 2.267 minus 2X. And we have concentration for each, because this is concentration, then this X also be concentration. And then we just write the formula for Kc. So Kc will be HBr raised to second power over H2 and Br2. Just plug into number. Let this equal to 2.18 times 10 to the 6th power. The rest just solve this equation, quadratic equation. Right? But for this case, you find x times x is x squared, right? So this is a little bit easier than the regular quadratic equation. Since this is x squared, this is squared, this is also squared, so we can or root. Right. So this is easier than regular quadratic equation. You get square root is 1267 minus x. Root x squared is x. And the right side, 10 to the sixth power square root is 10 to the third power. Then you just put this into calculator, square root of 2.18, which is 1.48. Now is this easy? This is a single variable linear equation. So 1.48 times 10 to the third power, so 1480 x. Move this x here. Right? 0.267 minus x equal to 1480x. Then move this to here. Become the 1481x equal to this. Then x will be 0.267 divided by 1481. If you oh, sorry, I mistake there. This is not a minus x, minus 2x. Minus 2x. Minus 2x. And this will be 1482. So use calculator, you can easily get 1.8, 1.8 actually. Times 10 to the negative 4 so. When we will get x, then we can easily get the concentration of H2 will be equal to Br2 equal to x. Where HBr concentration will be 0.267 minus 2x. 0.267 minus 2x. And this will be 0.26 minus 2 is 3.6. 3.6 is 0.00036 and 2.267 and 26664. Are you okay with this? This is a little bit harder, but this is a very common example sort of equilibrium problem. Okay. You need set initial and change set a variable. Here we set a variable is H2 is x, Br2 is x, then HBr will be 2x. If you prefer set HBr is x, because this serves as a reactant, right? We explained because it's starting with HBr only. These two, nothing there. If you prefer set HBr reacted to x, then these two will be half x. Because every 2 HBr only produces 1 H2 and Br2. Either way, you set this x, this becomes half x or 0.5x. Or I prefer set this to x, then HBr is 2x. Either way, if you set this x, then you solve the equation. Then HBr will be 0.26 minus x, and these two will be half x. Of course, in two situations, x value will be different since you set this x equivalent for this method with the 2x. Either way you prefer, which is method is easier. And anyway, they're similar as this. Just use your way to set which one is x. Okay, Friday, quiz 5. Let's stop.